All right, now that we've learned about bond polarity, which is how are the electrons shared between just two different atoms, we're going to focus on the molecular polarity, which is overall looking at the big picture, how are electrons shared. Okay, and there are three types of molecular polarities. One is that it is polar, which means that our electrons are shared. Okay, so we do have some sharing, it's not a give and a take, but one side of the molecule has a slightly positive or slightly negative charge. And this is because the molecule is not completely symmetric. So what happens is that there's an uneven or unequal distribution of charge, which we call a dipole. Oh, that's really bad. Moment. Okay. What a dipole means is that there's two poles. Okay, so it's got an unequal dipolar movement. Then we also have nonpolar molecules. Nonpolar molecules exist when electrons are shared, so they're just like these guys. But what happens is that they are completely symmetric or there's an equal distribution of charge. Okay, so what we'll show it in a little bit. But what's happening is that it actually is not, there's not one pole going in one given direction, that it would be balancing itself out. In an ionic compound or an ionic molecule, electrons are given and taken entirely. So there's no sharing. So once again, there's polar, nonpolar, and ionic. All right, so here are some differences between the polar and nonpolar. Notice that we've got these little bonds going on, so that just shows that they're sharing those electrons. So when I look at this overall shape, I notice that it is heavily sided towards the A. So within this bond, okay, because this is a bond because there's just two different elements, it is heavily going towards the A as far as the electrons go. So this would have polar bonds and would be considered a polar molecule. Between A, B, and C on this second one, I notice that between A and B that the electrons are going towards A, and between B and C that the electrons are primarily going towards C. But if I were to look, so this one does have polar bonds. But if I were looking at the overall structure of this and I were to like divide this in half, it is split evenly. And if I were to try to balance it and I put my finger right in dead center of B, it would be perfectly balanced because A is pulling just as much as C. So what happens is those dipole moments actually cancel each other out. Okay, so even though it has polar bonds, this is considered a non-polar molecule because it's balanced out. Now, an A, B, C at the last one, if you look at A versus B, there's a polar bond going towards B, and then B versus C, there's a polar bond going towards C, meaning that C is the most electronegative, then comes B, then comes A. And if I look at overall and I tried to put my finger in the dead center, it would still tilt heavily towards the C area because it is so electronegative compared to that A. So this would have both polar bonds and would be considered a polar molecule. The good news is that it's very easy, even if you try to visualize it. There are other ways that you can determine whether the molecule is polar or not, and it's as easy as 1, 2, 3. You do have to have these steps memorized. So the first one, is it a hydrocarbon? What is a hydrocarbon? A hydrocarbon in this class for this unit is going to be made up of totally 100% hydrogen and carbon. So the only two elements you see are hydrogen and carbon. If you said yes to that, the molecule is considered automatically nonpolar. If no, then you have to move on to step 2. How to do that though? You have to figure out the Lewis dot structure of the molecule. So what you can do even before you draw any of these structures, you can identify if it's a hydrocarbon. If it's a hydrocarbon, then you automatically know that the molecule overall is nonpolar. Okay? Then you move on to step 2 if that's not the situation, and you have to determine the shape. So is the shape bent or trigonal pyramidal, meaning does it have any lone pairs? If it does have lone pairs, then the molecule is going to be considered polar. If not, then you have to move on to the next question. So if you don't have lone pairs, then you move on to step number 3. And then the last question is, are all the atoms attached to the central atom the same? If yes, the molecule is considered nonpolar. If no, then it is considered polar. So let's do an example with CH4. First off, is it a hydrocarbon? Well, we've got 1 carbon and we have 4 hydrogens, so it's only made up of a carbon and a hydrogen, so therefore it is yes, so this would be considered nonpolar, and I don't even have to answer the last 2 steps. Let's try the next one. Is the molecule a hydrocarbon? Well, I've got S and F and 6. So I don't have a hydrocarbon. I don't have hydrogen nor carbon, so I've got to move on. Okay, then I need to figure out its shape. Is it bent or trigonal pyramidal? Well, this, looking on my shape sheet, is octahedral, which means that I need to move on to my last question. Are all the atoms attached to the central atom the same? Well, I look at my central atom of S, and it's surrounded by 6 different elements of all F's, so it would be yes, so the molecule is considered nonpolar. Now let's do the next one, NH3. Is this a hydrocarbon? I do have hydrogen, but I don't have carbon, so it is not. So I need to figure out my shape. Looking at my shape, it is attached to 3 different things with 1 lone pair, so this would be trigonal pyramidal, which is one of these shapes, meaning it did have a lone pair, and I could even see it. So if it has a lone pair or is that shape, then the molecule is polar. So therefore, I know that it is considered a polar molecule. I don't need to move on to step 3. Next one, I have CH2O. Is it a hydrocarbon? Well, it does have carbon and it does have hydrogen, but it also has that oxygen. So right now that is considered no. So we're going to move on to figure out the shape. This shape, the central atom is attached to 1, 2, 3 things with 0 lone pairs. Okay, so therefore it is considered trigonal planar, which is not bent or trigonal pyramidal, so I would say no. And then the last question, are all the atoms attached to the central atom the same? Well, this carbon is attached to hydrogen, 2 of them, but it's also attached to an oxygen. So no, they are not all attached to the same thing, so this molecule is considered polar. So it is a polar, not a molecule polar, it's a polar molecule. All right, hopefully you have these steps written down and you can easily, once drawing the structure, identify whether the molecule is polar or not. Have a great evening.